Imagine you are drifting in open space and Saturn is in front of you. Not in a photograph, not on a screen, right there. Close enough that the rings fill your entire field of vision from edge to edge. A vast, silent disk of ice and rock stretching 280,000 kilometers in every direction, glowing faintly gold in the light of a sun that looks half the size it does from Earth. The planet itself hangs beneath the rings like a lantern, banded in cream and amber and pale sienna, wrapped in clouds that move in slow, majestic spirals. It is the most beautiful thing you have ever seen in your life. You feel peaceful here. You feel small in a way that doesn't frighten you. You feel, for the first time in your life, like the universe is a place of quiet and wonder. And then, something happens to the ring particle closest to you. It moves, not slowly, not gently. It streaks past your visor at 36,000 kilometers per hour. A chunk of ice the size of a house, moving fast enough to circle the Earth in just over an hour. And the shock wave hits you a half second later, and you understand, all at once, that you have been completely wrong about this place. Saturn doesn't want you here. And it is about to make that very, very clear. There is a reason Saturn has been called the jewel of the solar system, for as long as humans have pointed telescopes at the sky. Galileo saw it in 1610 and thought it was 3 planets clustered together. His instrument wasn't powerful enough to resolve the rings, so he described Saturn as a planet with ears. 45 years later, Christian Huygens figured out the truth. A disk, a ring, a halo of something encircling the planet in a perfect, improbable band. The revelation sent ripples through the scientific community of 17th century Europe. Nothing in their model of the universe had prepared them for the idea that a planet could wear a crown. And even now, 4 centuries later, with everything we know, Saturn still stops people cold. When the Cassini spacecraft, the most sophisticated planetary probe ever built, arrived at Saturn in 2004 and began transmitting images back to Earth, scientists at NASA's Jet Propulsion Laboratory gathered around monitors and went quiet. Engineers who had spent decades in aerospace, people who had seen images of every planet in the solar system, people who built machines for a living and thought in equations, they went quiet. Because even for them, the reality of Saturn up close was something that bypassed the analytical brain entirely and hit something older, something closer to awe. The rings looked like brushstrokes. The planet looked like a painting. The golden light of the distant sun fell across the cloud bands in a way that made the whole system look lit from within, like a Japanese lantern hanging in the black. But the Cassini data was also coming in, and the data was something else entirely. The rings up close are not peaceful. They are not silent. They are a war zone operating at astronomical scale, a constant, ongoing collision of billions of particles ranging in size from specks of frost to boulders the size of houses, all of them moving at speeds that make rifle bullets look slow, and all of them crashing and grinding and shattering and reforming in a process so violent it should have destroyed the entire ring system millions of years ago. But something is wrong. The rings are young, geologically, cosmically young. The ice is too clean, too bright, too pristine for something billions of years old. Scientists now believe the rings may have formed only 100 million years ago, when dinosaurs still walked the Earth. Before that, Saturn may have existed for billions of years as a plain, ringless planet. Something was destroyed to make those rings. Something was torn apart. And the same forces that did that are still here, still active, still operating, on a scale you are about to understand. Let's start with the most fundamental danger, the one you can't see, can't touch, and cannot escape from the moment you enter Saturn's sphere of influence. Gravity. Saturn is 95 times more massive than Earth. Not 95 times bigger, 95 times more massive. That is a number that sounds large but doesn't land until you translate it into something physical. Standing on Saturn's cloud tops, if there were something to stand on, which there isn't, but we'll get to that. You would weigh approximately 1.065 times what you weigh on Earth. That sounds almost manageable. Almost. But that number is deceptive, because Saturn's gravity doesn't just pull you down. It is the organizing force of an entire planetary system that extends hundreds of thousands of kilometers in every direction. Saturn's gravitational reach is so enormous that it has captured 146 confirmed moons. 146. The largest of them, Titan, is bigger than the planet Mercury. Another, Enceladus, has a liquid ocean under its icy crust that scientists believe could harbor life. Saturn didn't just pull these worlds into orbit, it owns them, completely and permanently. And the moment you enter this system, Saturn owns you too. From the distance of the rings, Saturn's gravity would begin accelerating you. Not dramatically at first, you might not even notice, but the acceleration is constant and it compounds. And the closer you get, the faster you fall. And the faster you fall, the harder it becomes to do anything other than continue falling. There is no hovering near Saturn. There is no pausing to take in the view. Gravity has its own agenda, and its agenda is to pull everything toward the center, always, without exception, without mercy. This is the trap that closes before you even know you've walked into it. But here's the problem. Gravity alone wouldn't kill you. Gravity alone is almost peaceful. It's just acceleration, just a feeling of falling that, in the vacuum of space, is indistinguishable from floating. The killing starts when gravity interacts with everything else Saturn has waiting for you. Let's talk about what the rings actually are, because almost everything you picture when you hear the word is wrong. They are not solid. They are not one thing. They are not the smooth, continuous bands they appear to be from Earth. Up close, the rings of Saturn are a dense three-dimensional storm of individual particles. Billions upon billions of fragments of ice and rock, each one in its own orbit around Saturn, each one moving at its own precise velocity, and each one in constant, violent interaction with the particles around it. The Cassini spacecraft spent 13 years studying the rings, 13 years of continuous data collection, and scientists are still processing what it found. What they've confirmed is this: the rings are between 10 meters and 1 kilometer thick in most places, absurdly thin for their width, like a sheet of paper stretched across a football field. But within that thickness, the density of particles varies wildly. There are regions of the rings so packed with debris that Cassini had to be shielded with its own solar panels and dish antenna during ring plane crossings to protect its instruments. The particles in the densest ring regions are colliding constantly, not gently. These are impacts between objects ranging from ice grains to house-sized boulders, on all of them moving at tens of thousands of kilometers per hour relative to each other, all of them shattering, grinding, and reforming in a process that generates heat, ejects material, and produces what researchers call propeller structures, gaps and waves in the ring fabric caused by embedded moonlets shepherding the particles around them. Now imagine you are moving through this at the orbital velocities required to stay near Saturn. You're not drifting, you're flying. A particle that you don't see, a fragment of ice smaller than your fist, moving at a relative velocity of even a few hundred meters per second, would hit with the energy of a car crash. A larger fragment, say a meter-wide boulder, which is absolutely common in the B ring, would hit with the energy of a large bomb. Cassini survived by threading the gap between the innermost ring and Saturn's atmosphere, a region called the Grand Finale Gap, 22 times in its final months of operation. Each pass was calculated with extraordinary precision. Each pass was a risk. And Cassini was a machine built to withstand exactly this environment, with instruments specifically designed for it. You are not Cassini. And it gets worse. Let's say somehow you've made it through the rings. Let's say the probabilities went in your favor and you descended toward the planet itself, toward those gentle-looking amber cloud bands. toward what your eyes are telling you looks like weather and air and the possibility of something breathable. Your eyes are lying. Saturn's atmosphere begins as hydrogen and helium, the two most abundant elements in the universe, and the building blocks of stars. There is no oxygen. There is no nitrogen. There is nothing your lungs could use. The moment you tried to breathe Saturn's atmosphere, you would inhale a mixture of hydrogen, helium, methane, ammonia, and water vapor that your body would recognize as nothing, process as nothing, and respond to by suffocating within minutes. But suffocation would be the least of your problems. The winds in Saturn's upper atmosphere reach 1,800 kilometers per hour. That's 5 times the speed of the most powerful hurricane ever recorded on Earth. And unlike Earth's hurricanes, which are driven by warm ocean water and constrained to the tropics, Saturn's winds circle the entire planet, equator to pole, in unbroken bands of shear force, where two bands moving in opposite directions meet, and the turbulence would tear apart any structure ever built by human hands within seconds. And the temperature at the cloud tops is minus 178 degrees Celsius, so you are being frozen, suffocated, and shredded simultaneously, and you haven't even gone deep yet. Descend further, past the ammonia ice clouds at the top, into the ammonium hydrosulfide layer below, into the water ice clouds below that. And the temperature begins to rise. The pressure begins to rise. Every kilometer downward adds another atmosphere of pressure on every surface of your body. At 10 kilometers below the cloud tops, the pressure has already reached 10 times what you experience at sea level on Earth. At this depth, breathing would be physiologically impossible, even if the atmosphere were pure oxygen. The pressure alone would begin collapsing the air spaces in your lungs. But it doesn't stop at 10 atmospheres. It doesn't stop at 100. As you go deeper, the hydrogen atmosphere doesn't just get denser, it begins to change. It transitions from gas to something thicker, heavier, stranger. The boundary between gas and liquid disappears. You are not in an atmosphere anymore. You are inside something more like an ocean, except the ocean is made of compressed hydrogen, and it is being crushed under the weight of a planet 95 times more massive than Earth. At approximately 30,000 kilometers below the cloud tops, the pressure reaches 3 million times Earth's atmospheric pressure. At this point, hydrogen undergoes a phase transition that exists nowhere on Earth and cannot be replicated in any laboratory using conventional means. It becomes metallic hydrogen, a state of matter in which hydrogen atoms are so compressed that their electrons are freed to flow between atoms, creating a substance that conducts electricity like a metal. The metallic hydrogen layer of Saturn is not a place. It is not an environment. It is a condition of matter that no object constructed by human civilization could survive for a fraction of a second. And this is where things change. Before you reach the metallic hydrogen, before the atmosphere has even fully transitioned from something recognizable to something from a physics textbook, you would pass through Saturn's storm systems. And these are not storms in any sense the word prepares you for. In 2010, amateur astronomers noticed a white spot appearing in Saturn's northern hemisphere. Within weeks, it had grown. Within months, it had encircled the entire planet. A storm band 300,000 kilometers long, visible from Earth with a backyard telescope, generating lightning bolts 10,000 times more powerful than any lightning ever recorded on Earth. Scientists called it the Great White Spot, and when Cassini turned its instruments toward it, the data came back almost incomprehensible. The storm's head, the leading edge where the convective plume was rising from deep in the atmosphere, was generating radio emissions so powerful they were detectable by instruments across the solar system. The turbulence it created was reshaping the cloud bands around it, reorganizing the atmospheric structure of an entire planetary hemisphere. It lasted for more than 200 days before the head was consumed by its own tail as the storm wrapped completely around Saturn and collided with itself. A storm that circled an entire planet. That consumed itself when there was nothing left to devour. And this wasn't unprecedented. Saturn experiences these great white spot events approximately every 30 Earth years, roughly once per Saturn year, and each one is catastrophic by any terrestrial standard. The last major one before 2010 was in 1990. Before that, 1960. Before that, 1933. They are periodic, they are enormous, and they happen whether anyone is watching or not. But here's what makes Saturn's storms uniquely terrifying. Beyond their scale, the lightning. On Earth, lightning is an atmospheric discharge between cloud layers or between cloud and ground. We understand it. We can predict it to some extent. We have learned to respect it, but not fear it absolutely, because its danger is localized. You have to be unlucky to be struck. Saturn's lightning discharges are 10,000 times more powerful. They last longer. They occur in massive clusters. Cassini detected storms with individual lightning strikes occurring hundreds of times per second, sustained for months. The radio emissions from these storms, called Saturn electrostatic discharges, were first detected by Voyager 1 in 1980, and for years, scientists debated their source because they were so powerful they didn't fit existing models of planetary lightning. If you were inside a Saturnian storm system, inside the cloud layer, surrounded by ammonium hydrosulfide and ammonia ice crystals, with winds at 1,800 kilometers per hour and lightning discharging at 10,000 times terrestrial intensity, every few seconds, there would be no surviving, there would be no shelter, there would be nothing between you and a bolt of electricity more powerful than anything on Earth, happening repeatedly, in every direction, without pause. But that's not even the worst part. Here's something Cassini discovered that fundamentally changed how scientists see Saturn, and that adds a layer of horror to everything you've been imagining. The rings are disappearing, not slowly. In some geological sense, that takes billions of years. They are disappearing at a rate that scientists, when they first calculated it in 2018 using Cassini data, undescribed as surprisingly fast. Ring material, ice and dust, is being pulled into Saturn's atmosphere at a rate of between 400 and 4,800 kilograms per second. Every second, Saturn is consuming its own rings. Every hour, thousands of tons of ice and rock are raining down into the planet's atmosphere, drawn inward by Saturn's magnetic field and gravity. This process is called ring rain. The ring particles become electrically charged by ultraviolet radiation from the sun. Once charged, they are no longer purely in orbit. They are subject to Saturn's powerful magnetic field, which channels them toward the planet's equatorial atmosphere, like water through a funnel. They fall, they burn up, they become part of the planet. At the current rate of loss, Saturn's rings will be completely gone in approximately 100 million years, maybe less. This means the rings that make Saturn the most visually spectacular planet in the solar system. The rings that have defined how humanity has pictured Saturn since Galileo's time, the rings that every image of Saturn in every textbook and documentary and piece of art has included, are a temporary feature, a moment, a phase. We are alive at the exact moment in Saturn's history when its rings are at peak visibility. In cosmic time, we are watching something in its final hours. But here's what this means for you, floating near the rings. The ring rain is occurring throughout the ring system. Material is constantly in motion, not just within the rings, but into the planet. And as Cassini discovered in its grand finale orbits, when it flew through the gap between the rings and the planet, this region is not empty. It is full of complex organic molecules, water, silica, and carbon-based compounds falling continuously from the rings above into the atmosphere below. Cassini's mass spectrometer detected molecules in this gap that were unexpected, complex, and not fully understood. Things that shouldn't be there according to existing models of how planetary rings work. Scientists are still analyzing the data. Something is happening in the space between Saturn's rings and Saturn's atmosphere that we do not yet fully understand. and you are floating in the middle of it. But it gets worse. We have talked about the planet. We have talked about the rings. But Saturn's system is larger than both, and one of its moons adds a dimension of horror that is almost philosophical. Titan is the largest moon of Saturn and the second largest moon in the solar system. It is larger than Mercury. It has a thick nitrogen atmosphere, the only moon in the solar system with a substantial atmosphere. It has lakes and rivers and seas, not of water, of liquid methane and ethane, hydrocarbons so cold they exist as liquid at minus 179 degrees Celsius. Titan has a methane cycle, the way Earth has a water cycle. Methane evaporates, forms clouds, rains back down, flows in rivers to the seas, evaporates again. It rains on Titan. It rains hydrocarbon, and somewhere in Titan's atmosphere, there are complex organic molecules, tholins, scientists call them, that form when ultraviolet radiation from the distant sun hits nitrogen and methane in the atmosphere. These are the same kind of molecules that, on early Earth, are believed to have been precursors to the chemistry of life. Titan might not be uninhabited. We genuinely don't know. But here is what makes Titan relevant to the horror of Saturn's system specifically. Titan orbits Saturn at a distance of about 1.2 million kilometers. And over billions of years, tidal interactions between Saturn and Titan have been pushing Titan slowly outward, the same process that is pushing our own moon slowly away from Earth. In 2020, a study using Cassini data found that Titan is moving away from Saturn about 100 times faster than previous models predicted. This matters because it means the tidal interaction between Saturn and Titan is far more powerful than anyone expected. The forces shaping Titan's orbit, the gravitational kneading of the moon's interior by Saturn's pull, are also heating Titan from within. They are keeping Titan's subsurface chemistry active, and still they are driving the processes that might be making Titan, in some narrow sense, compatible with life. And they are the same forces that, for objects closer to Saturn, don't push them away. They pull them apart. Closer to Saturn, inside what's called the Roche limit, the boundary within which tidal forces overcome the gravitational cohesion of a solid body, no moon can exist in one piece. Any object that crosses the Roche limit is shredded. Its own gravity is not strong enough to hold it together against the tidal forces of Saturn's pull, and it breaks apart, the pieces spreading out into a ring. This is how the rings were made. This is what Saturn does to things that get too close. And the Roche limit for Saturn is not deep inside the ring system, buried in some safely distant interior. It extends out to 140,000 kilometers from Saturn's center, well within the ring system, well within the region of space you've been imagining yourself in. If you were a rigid body, if you were anything more substantial than a freely floating speck, Saturn's tidal forces would be working on you constantly, pulling harder on whichever part of you is closest to the planet, trying to stretch you, trying to separate you, trying to reduce you to the same dispersed ring material that everything else became. The rings of Saturn are not a monument. They are a graveyard, and Saturn is still hungry. And this is where everything becomes real. We need to talk about one more thing, one more layer of danger that operates invisibly, that you couldn't see or hear or feel until it was already killing you. Saturn has a magnetic field, a powerful one, 578 times more powerful than Earth's. This field extends millions of kilometers into space, creating what's called a magnetosphere, a region of space dominated by Saturn's magnetic influence, filled with charged particles trapped and accelerated by the field's lines. Earth's magnetic field protects us. It deflects charged particles from the sun, the solar wind, that would otherwise strip away our atmosphere and bombard our surface with radiation. Without it, Earth would be Mars, a cold, thin atmosphered, likely lifeless rock. Saturn's magnetic field is 578 times stronger, and it does the same thing. Except at Saturn's scale, with Saturn's intensity, the trapped charged particles in the magnetosphere aren't deflected. They are accelerated to enormous energies and concentrated into radiation belts around the planet that are extraordinarily hostile to both electronics and biology. Cassini's radiation instruments had to be carefully managed throughout the mission. The spacecraft was not sent through Saturn's inner radiation belts at all during its primary mission. The radiation was too intense, the risk of instrument damage too high. Only in its final months, in a mission phase that was explicitly designed as a controlled self-destruction, the grand finale, was Cassini sent through the ring gap and the inner radiation environment, because by that point, the spacecraft was going to be destroyed anyway. NASA sent Cassini to its death, partly because that was the only way to get the data that region of space contained. If Cassini, a machine with no living biology, hardened against radiation, carrying instruments designed to measure exactly this environment, was too vulnerable to survive in Saturn's inner magnetosphere indefinitely, what does that tell you about a human body? Unshielded radiation exposure at the levels found near Saturn's inner rings would produce acute radiation syndrome within minutes, cellular damage, DNA strand breakage, neurological disruption. Within hours, organ failure would begin. Within days, even if somehow extracted from the environment and provided with emergency medical care, survival would be unlikely. The magnetic field that makes Saturn's auroras so beautiful, the shimmering curtains of light at its poles that Cassini photographed, and that look in those images, like something sacred, is simultaneously a machine for killing anything biological that gets too close. There is no safe approach. There is no safe distance within the system. There is no version of this where you come back. Let me tell you what Saturn actually is. Underneath all the physics and the data, Saturn is a boundary marker. It is the solar system telling you where you stop. It marks the edge of the region where the conditions that produced you, liquid water, moderate temperature, stable chemistry, the slow accumulation of complexity that eventually became thinking, feeling, wondering beings, where all of that becomes irrelevant. Beyond Saturn and in Saturn itself, the universe operates under different rules. Rules that don't include you. Our rules that were set before life existed on Earth and that will continue to operate long after the last living thing in this solar system draws its last breath. The Cassini spacecraft ended its life on September 15, 2017. After 13 years of orbiting Saturn, after returning hundreds of thousands of images and an ocean of data that scientists are still analyzing years later, it was deliberately plunged into Saturn's atmosphere. The decision was made to protect Titan and Enceladus, those moons with their subsurface oceans and their potential for life, from any possibility of contamination by Earth biology. So Cassini was burned, broken apart by the atmosphere, torn into its component molecules and absorbed into a planet it had spent 13 years studying. The most sophisticated machine humanity ever sent to the outer solar system was torn apart by the planet it loved. In the final 91 seconds of signal transmission, before the atmosphere overwhelmed Cassini's thrusters and the antenna lost lock with Earth, the spacecraft was still sending data, still measuring, still recording. The last thing Cassini told us was about Saturn's atmosphere, about the place it was being destroyed inside of. And then the signal stopped. There is a version of the universe in which Saturn is just a planet, just physics, just gas and gravity, and ice and electromagnetic fields operating according to equations that have been understood for centuries. And that version is accurate. That version is true. But there is another version, the version you feel when you look at an image of Saturn and something in you goes quiet, something older than language, something that existed before your ancestors had words for what they felt when they looked up at the night sky. That part of you knows what Saturn is. It is a reminder that the universe is not scaled for us. It was not shaped with us in mind. Its largest structures are structures in which we are irrelevant, too small to matter, too fragile to survive, too brief to register. We are alive in the one narrow band of conditions in this solar system where life is possible. One planet, one distance from one star, one magnetic field, one atmospheric composition, one temperature range. Remove any one of these and we vanish. And we live, all of us, our entire civilization, and every human who has ever lived or ever will live, within a film of habitable space so thin that from Saturn's distance it would be invisible. Saturn will be here long after we are gone. The rings will rain down and disappear in 100 million years, and the planet beneath them will continue, banded and golden, circled by its 146 moons, generating its lightning and its storms and its impossible interior physics, in silence and in darkness, and in absolute, perfect indifference. It does not know we found it beautiful. It does not know we sent a machine to study it for 13 years and then said goodbye. It does not know we exist. And somehow, that is the most terrifying thing about it.